Hi, in this video, we are going to share about correlation analysis, and how to run it in SPSS. The bivariate Pearson correlation produces a sample correlation coefficient, R, which measures the strength and direction of linear relationships between pairs of continuous variables. By extension, the Pearson correlation evaluates whether there is statistical evidence for a linear relationship among the same pairs of variables in the population, represented by a population correlation coefficient, ρ. To use Pearson correlation, your data must meet the following requirements. 1. Two or more continuous variables, example, interval or ratio level. 2. Cases must have non-missing values on both variables. 3. Linear relationship between the variables. 4. Independent cases, for instance, independence of observations. There is no relationship between the values of variables between cases. This means that the values for all variables across cases are unrelated. For any case, the value for any variable cannot influence the value of any variable for other cases. The Bivariate Pearson correlation coefficient and corresponding significance test are not robust when independence is violated. 5. Bivariate normality. Each pair of variables is bivariately normally distributed at all levels of the other variables. This assumption ensures that the variables are linearly related. Violations of this assumption may indicate that nonlinear relationships among variables exist. Linearity can be assessed visually using a scatterplot of the data. 6. Random sample of data from the population. 7. No outliers. The null hypothesis, H0, and alternative hypothesis, H1, of the significance test for correlation can be expressed depending on whether a one-tailed or two-tailed test is requested. Two-tailed significance test. H0, ρ equals 0, the population correlation coefficient is 0. This means there is no association. H1, ρ does not equal 0, the population correlation coefficient is not 0. This means a non-zero correlation could exist. As for one-tailed significance test, H0, ρ equals 0, the population correlation coefficient is 0, means there is no association, while H1 will have two conditions, whether ρ greater than 0 that means a positive correlation could exist, or ρ is less than 0, means a negative correlation could exist respectively. Correlation can take on any value in the range, -1 to 1. The sign of the correlation coefficient indicates the direction of the relationship, while the magnitude of the correlation, in other words, how close it is to -1 or +1, indicates the strength of the relationship. -1, perfectly negative linear relationship. 0, no relationship. +1, perfectly positive linear relationship. The strength can be assessed by these general guidelines. 0.1 less than R less than 0.3 means small, weak correlation. 0.3 less than R less than 0.5 means medium, moderate correlation. 0.5 less than R means large, strong correlation. Your dataset should include two or more continuous numeric variables, each defined as scale, which will be used in the analysis. Each row in the dataset should represent one unique subject, person, or unit. All of the measurements taken on that person or unit should appear in that row. Just a reminder, you should reshape your data to wide format before you compute the correlations, if the measurements for one subject appear on multiple rows. For example, if you have measurements from different time points on separate rows. Perhaps you would like to test whether there is a statistically significant linear relationship between two continuous variables, weight and height. In the sample data, the variable height is a continuous measure of height in inches, and exhibits a range of values from 55.00 to 84.41. And the variable weight is a continuous measure of weight in pounds, and exhibits a range of values from 101.71 to 350.07. To run the bivariate Pearson correlation, click Analyze, Correlate, Bivariate. Select the variables height and weight and move them to the Variables box. In the Correlation Coefficients area, select Pearson. In the Test of Significance area, select your desired significance test, two-tailed or one-tailed. We will select a two-tailed significance test in this example. Check the box next to Flag Significant Correlations. Click OK to run the bivariate Pearson correlation. Output for the analysis will display in the output viewer. The results will display the correlations in a table, labeled Correlations. As we can see, in box A, correlation of height with itself, R equals 1, and the number of non-missing observations for height, N equals 408. In box B and C, the data are the same, where correlation of height and weight, R equals 0.513, based on N equals 354 observations with pairwise non-missing values. Meanwhile, in box D, correlation of weight with itself, R equals 1, and the number of non-missing observations for weight, N equals 376. Box B and C are identical, because they include information about the same pair of variables. In box B, as well in C, we can see that the Pearson correlation coefficient for height and weight is 0.513, which is significant, p less than 0.001 for a two-tailed test, based on 354 complete observations. The correlations in box A and D are all equal to 1. This is because a variable is always perfectly correlated with itself. However, the sample sizes are different in box A, n equals 408, versus box D, n equals 376. This is because of missing data. There are more missing observations for variable weight than there are for variable height. If you have opted to flag significant correlations, SPSS will mark a 0.05 significance level with 1 asterisk, and a 0.01 significance level with 2 asterisks. Based on the results, we can state that weight and height have a statistically significant linear relationship, R equals 0.513, p less than 0.001. The direction of the relationship is positive. Example, height and weight are positively correlated, meaning that these variables tend to increase together. The magnitude, or strength, of the association is approximately moderate, 0.3 less than R less than 0.5. Visit us on Instagram. And stay tuned for our next video.